So welcome everyone to this case session. Today we are going to be having a presentation called Quality Matters, a new approach for detecting quality problems in web archives. And our presenter today will be Brenda Reyes Ayala. Sorry. Please correct my pronunciation. She'll be talking for about 20 to 25 minutes, after which there'll be questions from the audience, and please enjoy. The floor is yours.
Okay, I will just quickly share my screen here. Let's see. So you should be able to see my presentation. Can you see that? Okay, great. So my name is Dr. Brenda Reyes Ayala. I am from the University of Alberta, and I will be presenting today something called Quality Matters, a new approach for detecting quality problems in web archives. So first of all, what is web archiving? Well, I define web archiving as the process of preserving websites, collecting websites and preserve them to have them as a future historical record. And actually, this is a common practice that has been going on since the 90s. And it is done most famously by the Internet Archive, but it is also done by many universities and national libraries throughout the world, like at University of Alberta and our own Library and Archives of Canada. And can you see the Wayback Machine? Yeah. So kind of the most famous an example of web archiving is called the Wayback Machine from the Internet Archive. And the Internet Archive is located in San Francisco, California, and it is one of the world's largest libraries. And what they like to do, so they have the feature, they have something called the Wayback Machine. And what the Wayback Machine does, as you can see, is an interface where you can just type in any URL that you wish. In this case, I typed in the universityofalberta.ca, www.uofalberta.ca, and you can sort of time travel through this website as it was over time, right? And they have captures from 1996. So if I was curious, or I was a historian or a researcher, and I wanted to see what was the U of A doing in the year 2000, I can just, for example, click on the year 2000 and say, well, I wanted to know, you'll see that there is a version, or also known as a capture of the website from the year 2000. So I say, okay, June the 1st, 2000. And I click on it, and it takes a little bit of a while to load, but there should come up a website for the University of Alberta from that time period. There we go. It's starting to load. Depends on the connection. Yeah. Yep. So you can see that this is from June 2000, and this is the website of the university. And this is not just a screenshot. It is an actual archive website. You can actually click these links and actually navigate the website as it was at that time. Now, as you can see, it is not a perfect representation because there are some things missing here. For example, the A, I don't know where that is, right? Not the University of Alberta. And there are some images that are missing, and so this is not what I would call a amazing quality historical record, because we have some things that are missing that can actually be quite important. So going back to our presentation, this is the outline of what I'll be speaking about. So why quality matters in a web archive. So we already looked at the example of a regular website, quote unquote regular website, and what kind of quality problems can arise when something is being archived, but it can actually be even worse than that. So for example, this is a screenshot of an archive version of the campus map of the University of North Texas from the year 2004. Now, as you know, campus maps are interactive websites, actually applications that run on your browser, and they're highly interactive. Web archiving has difficulty actually rendering these types of things online. So you can see that not only all the images are missing, for an app such as this website has effectively become unusable. right? And we lack that part of the historical record. Okay. So as we know, it is common to see archive websites with no images or media or with broken links. So what happens when web archivists at different national libraries and universities come across that? Well, they actually have to manually check each and every website that they archive, manually inspect it, and make it go through a quality assurance process. So they have to detect the problem, check if there is a problem, detect it if there is one, and try to fix it. So as the number of archive website rises, quality problems grow to such a scale that human intervention is no longer enough to detect and fix them. So this is particularly true for archives and universities or even national libraries that have a legal mandate to, actually harvest or preserve, and if, for example, an entire domain. The Library and Archives of Canada often collects huge parts of the .ca domain. So there's obviously hundreds and thousands, maybe even millions of websites. And you can't really manually inspect hundreds of thousands or millions of websites for quality issues. So the research problem here is, unless we learn how to address quality problems in a web archive, we will soon be facing an incomplete digital historical record at a time when the record is crucial. So I defined there's something called correspondence, which I will get into the details later, but correspondence is a degree of similarity between an archive website and its live counterpart, right? And so my question is this: can an image similarity metric successfully distinguish between high quality archive websites and lower quality archive websites? And by that, I mean high quality, I mean web archives or archive websites that look a lot or they resemble exactly their original live counterparts, or lower quality archive websites that, as we've seen, they don't resemble anything that the original. And number two is, how effective are different similarity measures at measuring the visual correspondence between an archive website and its live counterpart, and which measure yields the best performance. So the purpose of the talk here is we examine how the visual correspondence of an archive website can be measured using popular image similarity metrics. And we try to do this in order to detect these problems. And using these measures, we evaluate how visual correspondence can be used as an indication of overall archive quality. So the assumption is here, the more that an archive website looks like its counterpart, then the better it is, the higher quality it is. So some literature reviews, things that have come before. So in 2015, McNally, Wakarook, and Devuti in CAIS examined the extensive removal of Canadian web government content and its impact on researchers. They said that, if this continued, then Canadian researchers will no longer have access to historical records. And they stated that web archiving programs were performing a crucial role in maintaining their role as stewards of government information. So some definitions of quality for web archives, there is Masson's, where he defines quality in a web archive as being made up of the completeness of the material archived within the target perimeter and the ability to render the original form of the site, particularly regarding navigation and interaction with the user. So we see some hints as to, the way the website looks should be as close as possible to the original. So 2011, Denev, Maseka, Spaniel, and Wickham introduced the sharp archiving of website captures, and they introduced two measures of data quality, blur and coherence. Blur being the expected number of page changes that a time travel access for a site capture would accidentally see. And the coherence is a number of unchanged in those coherently captured pages in a site snapshot. So coherence needed to be maximized in order to achieve a high quality capture. So what are the impact of missing elements in web archive quality? So some things that impact a missing a low quality website are the presence or absence of some files. So Brunel, Kelly, Salil, Dean, Weigel, and Nelson examine the importance of these missing elements and their impact on the quality. So they specifically focus on something called embedded resources, which are known as images, videos, or style sheets that are present in a website. And they play a key role in ensuring that an archive website looks and operates like the original. So for example, you can say that they propose a metric to assess the damage to an archive website caused by these missing resources. and they based it on 3 factors: the MIME size, the MIME type, the size, and the location of the embedded resource. Another example is Reyes Ayala, who created a model of information quality for web archives. And she talked about 3 important facets of web archiving: equality, correspondence, relevance, and archivability. For the purposes of this paper, I focus on correspondence, which I define as the similarity between the original and the archive website. Good correspondence requires equivalence, or at least a close resemblance between the two. So we want to ask 3 questions when we talked about correspondence. What is the visual correspondence? And where we're asking, does the archive website just look like the original? Does it resemble the original? 2, does it work like the original? Then we look at the interactional correspondence. When a user clicks on something on the live website, can the archive website replicate that behavior? And 3, completeness. Does the archive website contain all the elements of the original website? Okay, so the process that we followed here was to obtain a data set of archive websites and related data, clean it and extract it. We wrote and tested code that implemented metrics for quality facets of visual correspondence. We conducted analyses to understand the similarities and differences between all of these 3 metrics. And we solicited judgments of quality from human subjects and perform evaluation by analyzing which metrics most closely correspond to human judgments of IQ or information quality. So we have 3 data sets in our research. 2 of them from Canada, 1 of them from the UK. The first one is I Don't Know More, which is a topical web archive that preserves websites related to the I Don't Know More movement, which is a Canadian political movement encompassing environmental concerns and the rights of Indigenous communities. The 2 is the Western Canadian Arts Collection, which preserves the born digital resources created by filmmakers in Western Canada. Both of these collections are at the University of Alberta. And we also have the British Library's Open Access Web Archive, which are UK websites that can be made available online according to British legal deposit laws. So all of these are on the web. They're accessible. So what we did, our second step, was to write and test some code that tried to measure the visual similarity between archive websites and the original. So we created a set of tools available on GitHub called WUA Screenshot Compare. So what it does is it creates a seed list. It takes a list of URLs as inputs, and it goes through all the URLs. It goes to the archive version, and it creates, it takes a screenshot using a headless instance of the Chrome browser and the Puppeteer, which is the Python port of the Puppeteer screenshot software. It generates a list of all the archive versions of the live sites, and it takes screenshots. So this was not a trivial process, actually, unlike what we had, is that, for example, as you might have seen from here, archive websites have these little banners, that tell you, oh, you're looking at an archive website from the year 2000. So that was actually relatively difficult to remove from an archive website. And there's also the problem of link rot. Okay, the problem of link rot, which means that not all archive websites that have been preserved are actually online today, right? And this highlights the importance of conducting visual quality assessments early in the web archiving process when you can meaningfully compare the archive website to the original. So we conducted some analyses to understand the similarities and differences between the different similarity metrics. So these image similarity metrics have been used often in the computer graphics world to detect similarities and differences between images and to see if an image has been altered. So we have used 3 important ones: the structural similarity index, or SIM, SSIM, the mean square error, or MSE, and the vector distance, which is the distance between the RGB values of each screenshot. So, the SIM SSIM calculates similarity on a scale of -1 to 1. So it spits out a number, and 1 is perfect similarity. MSE calculates the similarity on a scale of 0 to infinity, where 0 is perfect similarity. And vector distance calculates similarity on a scale of 0 to 1, where 1 is perfect similarity. So if you're looking at for example, a measure 1 in vector distance, it means you're looking at 2 identical images. So some examples of what we did and the results generated by the software. This is what I would call a medium quality archive website. And here we have a screenshot of the current live website and the archive website. And this is from Trinity College at Dublin. So we see that there in the archive version, we see that the styling is missing, some images are missing, but we can sort of see some text there. So like this might be usable, right? So it's not completely gone like that map that I showed you earlier. So this, when you run it through the SSIM algorithm, this pubs out a 0.51. And you have to remember that 1 is perfect similarity. So they're like, oh, it's half there. Right? And C is 61,536, and the vector distance is 0.60 as opposed to 1. So they're like, well, it's kind of, we're halfway there, right? This is what I would call a low quality archive website. This is a screenshot of a play called Nye and Jenny. This was, again, a British Library website. This is a screenshot of the current live website, and this is the archive website, which is completely blank, right? So do these image similarity metrics reflect the quality? As we can see that they sort of do. So the SSIM for this was 0.28. That is very low, 1 being like perfect. MSC was 169,000. So that means these two images were really far apart in similarity. And vector distance is equal to 0.08. And you have to remember that 1 is perfect similarity. All right. So what do? We try to solicit judgments of quality from human subjects, and we use a rubric where we actually talked about what do we define as high quality, what do we define as medium quality, low quality, and no comparison. So I've gone all over all of these. Kind of high quality is like almost perfect, everything is there, and it looks like the original. Medium quality, it's like what I showed you. There's some content there, not exactly, but like the original, but some content there. Low quality. And no comparison means that there was a technical issue with taking the screenshot, or there was link rot where the page is no longer available, or maybe the website has changed so much that a comparison isn't really meaningful anymore. Right? So we solicited judgments of quality from human subjects. So we had 2 U of A librarians with web archiving experience, and we had 2 student RAs. They assessed the quality of the screenshots of each of these websites, and one of the researchers was responsible for checking the judgments for accuracy. Right, so some evaluation to see which ones were better than others, right? So MSC was the most difficult to interpret as it has no proper upper bound. So as we saw before, you can have a value anywhere from 1,000 to 5,700 to 5 million, right? So we're like, there's no upper bound really. So like, we're not really sure that we can determine the quality from this. So sometimes the vector distance would actually error out, or would sometimes yield inaccurate results, because sometimes there were screenshots that we found on our data set that were completely blank that had scores in the 0.5 or 0.6. So that, you would just look at that number and think, oh, like medium quality, right? But screenshot was actually completely blank. So it should be a very low number. So we decided that SSIM, or structural similarity index, was the best image for the task. So we try to perform some evaluation to see if there were meaningful differences. So we removed the screenshots labeled no comparison from the data set because you couldn't calculate, some instance. So we found that none of the actual image similarity measures were able to fully distinguish between low and medium quality archive websites. Therefore, we merged these 2 categories into something called the low/medium quality. So we perform an evaluation to see which ones were the best. So we created a balanced random sample of 100 screenshots with 50 images deemed to be high quality, 50 images that were low medium quality. We ran a Mann-Whitney U-test, and this was because the distribution was not a normal one we're talking about SSIM scores. To see if there were significant differences in similarity scores between high quality archive websites and low quality archive websites. And these were our results. P equals less than 0.001. Statistically significantly, that medium SSIM scores were statistically significantly higher for high quality websites than for websites judged to be medium or low quality. So the medium score for high quality was 0.95, and the medium score for medium/low quality websites were 0.65. And these were medium or low quality as judged by our human experts. So our conclusion is that similarity metrics are able to successfully distinguish between websites capture of poor quality and those of higher quality, but not necessarily medium or high or medium or low. And that the structural similarity index was the most able to successfully measure visual correspondence between an archive website and its live counterpart. So next step, this is just what we want to do. Our goal is to develop a comprehensive toolkit for automated or semi-automated quality assurance processes in web archives. And this is going to help web archivists all over the world to create better web archives in the future by being able to detect these problems and try to fix them. So thank you for your time, and I will be more than happy to take any questions or comments.
Thank you very, very much for your presentation. I think I will ask the first question because I don't have any others in chat just yet. I find this process of creating like automated tools for quality assurance or other sorts of research projects very, very fascinating. You had the idea of having multiple different types of image similarity tools, and one of them seemed to be more useful than the others. Was there any, like if you use them in parallel, ignoring the one that can go up to infinity, did that help like increase the accuracy any? Because if it did, that does raise an obvious trajectory that you might consider.
Mm-hmm.
Which would
well, we actually, when we ran these experiments, I'm sorry.
Go ahead.
When we ran these experiments, we ran everything in parallel. So for every single similarity metric we measure the differences between each and every pair of websites between the archive and the live. And we did do tests of significance for each and every one. However, it's just that we also went back and manually checked to see if the human judgment corresponded with the SSIM or the vector distance or the MSC. But again, we found we continually crept into problems with MSC because we're like, well, we're not really sure how we can categorize this. And we did see problems where there were some blank images that were judged as being low quality by our judges, but it would be kind of flagged or measured as being kind of medium quality by the vector distance. And we didn't see any of those things when it came from when we used the structural similarity index.
So in one of your slides, you had a distinction between medium quality and low quality, with one of the differences being the coherence of the intellectual content there. It seems as if you brought in another tool that wasn't visual based, but say semantic analysis, you might be able to like tack that into the system and say, as a way of distinguishing the low quality from the medium quality. Have you considered
probably? Oh, I'm sorry. So we're trying to like go step by step. This is just the visual correspondence because web archivists need like a quick and dirty way to, well, you know, I have 5,000 websites. So obviously the goal is for the software to say, oh, these 200 websites are low quality. So we can address, we can say, okay, we don't look at the rest of the entirety of the 5,000 websites. We just look at those 200 that are troublesome. There have been some other researchers have talked about comparing the language or the content of the websites, and actually the same people who did the work on embedded resources did propose that maybe we could look at the content. However, the memory bottlenecks, the storage requirements, the processing time, they actually acknowledge that this might not be the most efficient and fastest way to do it.
Fair enough.
Yeah.
All right. Well, while we're waiting for any other questions or raised hands, I just want to ask you, like, how do you feel about like what part are you the most excited about? Like you have a future direction you want to go on. What do you want to jump on first?
Well, I'm actually quite excited about interactional correspondence,
Mm.
which means that something like, well, can you interact with this website in the way that you can with the original? So when you click on something in the archive website, is that behavior replicated in the original website? So that's actually more difficult than just taking a screenshot, because you have to go and archive or get all the HTTP status requests. So we're like working on that right now, and that is challenging, but it's also very exciting. But I mean, what I ultimately want to do is be able to give this tool to the web archiving community and say, hey, you don't have to manually check these thousands of websites anymore. You can just focus on the ones that were deemed to be low quality and go by that. And it's going to make, web archiving programs are generally, they're underfunded. They have very few people working on them. The staff only works on them part-time. So there is a lack of resources for this. And if we give web archivists any type of tool that they can use to address these problems and detect them, then we just made their job a lot easier. So that's kind of like what I would like to do.
Oh, we got a question in the chat here. Thank you for the presentation. Very interesting study. This may be off topic, but would you have any recommendations regarding web archives similar to the Wayback Machine, where we can simply input a URL for any websites to see if it was archived? I'm only familiar with Wayback myself, but if you know of another, I'd love to hear it too.
Yeah, well, there's kind of like a couple of ways. There's something called, I believe, the Memento Time Map, MEMENTO. And what it will do is you input a URL and it will tell you who has that archive website around the world. So maybe the Internet Archive has it, but maybe the University of New Hampshire has a copy, and maybe the British Library has a copy. So it'll tell you where that, if that website has been archived by anyone around. And the purpose of that is to be able to use more resources than just the Wayback Machine. You can also, what you can do is, also the other way would be to like try to manually check with a web archiving institution if they have a copy of that website. But this would be a more time intensive process, because you have to go, if you don't know who has it, then you have to ask around a lot before you find it.
One thing I've done in the past is use the Google cache, but that's really hit or miss.
Yeah, that's true. And it has become a lot less visible and accessible over time. I remember when Google first started up, I used to always use the Google cache, and remember that Google's API changes a lot. So if you want to like extract data from the Google cache, I think they limit you to X number of websites or X amount of data. You can't just like request 50,000 websites from them on a whim. I have tried to retrieve like a massive number of search results from Google, and they limit you to like 20. So yeah. So, like with a private company, you run into issues, that you might not with like, a public web archive, nonprofit, something like that. So yeah, I see that you posted the web. Yeah, the Memento web. Yeah, that's a good one. It's kind of the quickest and easiest way to do that.
All right. I think that might be it for questions, and we're coming up on the half hour anyway. So I just want to say thank you very much for your presentation. That was very interesting. As someone who uses web archives all the time for finding the forum that went offline, 5 years ago, to find that one post that I can barely remember. Thank you very much for your efforts.
Yeah, thank you so much.
All right. I will be. Oh. What a great project. So glad you're doing this work. It looks like a lot of people have the same feeling as I do.
Oh, thank you. And we just got funded by SSHRC. So sure.
Excellent. Congratulations.
Project. So hopefully we'll have some news of some new developments.
Excellent. All right. In that case, I am going to end the live stream, and I hope to see all of you at our next session on Wednesday, or maybe, no, tomorrow, I think, actually. Anyway, see everyone later.